Hi there, how's things? Sorry I haven't published videos there in the last week or so. I've been a bit up the walls. I was going to do one today on programming the ESP32 uh, via a dedicated application as opposed to using Visual Studio Code to flash the memory into it. But something arrived in the mail today, and I decided to do a quick video on that, and I'll do the other one later. Okay, so what arrived in the mail? Well, it had been myself and a colleague of mine. We've been looking around for other boards to use for ESP32. Specifically, we wanted to have a look at ones that did 4 to 20 milliamp and had some additional features on it. We've all seen, packed it away, the likes of the Liligo and the Olimex and that, and they're all grand boards. Um, but, they're really designed for doing projects with. So we wanted something that had a lot of, I suppose, feature rich and had a lot of IO and stuff on it. And so we came across this website on this board, and this board seemed very interesting. So it has decent connectors on it that you can screw terminal in. It comes in a case, obviously. It's not even IP1 rated. You can stick your finger in there, and but it is DIN rail mounted, so you can put it in a box. And so we saw this and decided to have a bit of a punt on it. And on their website, I think the most stripped back one, and I'll throw it up there in a moment, is 30 or 40 euros, or maybe 100 euros. Can't really remember. We ordered this about 3 or 4 weeks ago, and it, as I said, it arrived this morning. So we took a punt on it, and we ordered the, if you like, the premium kit, which I think was around 200 euros, including shipping to Ireland. And it was from a company called Kincony, probably pronouncing that wrong. Again, I'll put that up. I'll put their name up there in a second as we go through the data sheet, and we'll have a look at it. I'm just loosening the external screws just so I can take out the board. Of course, I had this done before I started recording, and then while I was talking there, I was floating around the screws and I've actually tightened them up. I'm just going to get a screwdriver. Okay, so I have the cover off, and this is what the board looks like. Hopefully that'll focus in there. Only issues that I have so far with it are that there is no keys in the sense that you can put in this connector across here, so you could actually force it into the wrong one. Now they have color coded it and that, so you know, all things being equal, it shouldn't be a mistake that someone now in the field should make. However, where people can do stuff wrong, they will. So that has plug-in connectors on one side. That's just the bottom with the DIN rails. Yeah, it seems okay. The injection molding, just felt, it's a bit here, but there's recessed here. So ideally, you'd put a sticker with your own name and brand of product on. The bottom of the case just fell in. Okay, so here's the board itself. So as I said, there was different options on the website. So we opted for one with an LTE modem on it, which has been fitted and all. So that was nice of them. There was also came with a 433 megahertz receiver, which is there, which you can obviously unplug. And what I'll do is I'm going to throw up the circuit diagram and on it and show you all the stuff that's meant to be on it. Now I haven't tested this yet, and I will do so, and I'm going to do that and write some code and have a look there. I'm just going to have a look at the ESP. Can't remember what one. It's a room. Uh, so it seems to be an ESP 32 straight up, not an S1 or anything. Okay, so it doesn't have an external aerial, so it's using just the inbuilt one. Does obviously have a LAN connection. The board itself seems to be quite well made. Uh, it looks like I've had a look over it when I took out the packaging, and it's really clean. And yeah, as I said, there's nothing to the naked eye that I can find wrong with it. The solder connections on this row of connectors here, and these ones on the connectors here, I know you can't really see them on my camera here, are really clean and they look like decent tracks. So I'm actually very impressed with the quality of the board, and it feels quite substantial as well. So yeah, from the look of the build, it looks quite good, and there's some nice features according to the documentation anyway. There's like there's all buttons for the I/O. So what I'll do is I'm just going to put up on the screen the manual of it there. We can have a look at what's meant to be on it. So the documentation is a bit Chinese English, and so yeah, it is a regular ESP32. Nothing wrong with that. And it's the S. So I ordered the S one, which is this one here with the blue connector. And the reason I ordered the S was because I wanted RS485 on it. And that's what the blue connectors are, is the RS485. So it does look very much like this. This is a version 1.0, whereas the one I've got there is a version 1.2. And why is that important? Well, I think that's going to be important for where it talks about the I/O on it. So you can see this is where the 433 megahertz receiver plugs in, and this is where the you can get a GSM, or we have the LTE one. There's a circuit diagram there for the power and where the core is, and there's the pinouts for the ESP32. I don't know, I haven't even powered this up. I don't know if it comes with any code on it for testing or not. You can see there's the programming, there's the digital inputs, the analog inputs, which is what I want to come back to in a second. Relays output, and you can see, yeah, the relays look fine. There is a humidity sensor built onto it, so used for testing. There's a little buzzer, which is handy. Something I actually noticed there when I was looking over it, and I don't know if it, yeah, it's actually here. It has a WS8. I never remember the number of these. 2812. 2812, yeah, WS2812. And what they are, if you haven't seen them before, are these addressable LEDs. So I have a strip of them here, and you can do, these are amazing. You can do lovely matrix displays with them. And they're essentially, they call them addressable because you send off 24 bits of color, RGB color, and the first one sniffs off the first 24 and truncates it. So if you have two of them, you send 24, 24. So the first one takes off the first 24 bits, and the second one captures the next 24 bits. If you have three LEDs, you wire them up all in series. There's 4 lines. There's the power, there's the DI, and the DO, digital in, digital out. And you wire them up in series. And if you have 4, 5, or 6 of them, you send 4, 5, or 6 times 24 bits. And the first one takes the first packet, the next one takes the next packet, the next one takes the next one, the next one takes the next one. And that means, and you can run up to 1024 of these. And you can refresh them at 30 frames per second. So that's a line of, if you like, high resolution. And 30 frames per second gives you some motion. So the idea of these is, though, could you imagine if you had to wire up 1024 LEDs? Well, first of all, you wouldn't have the pins on any micro. Where this, because it's all the one pin and it sends out a pulse train, it works really well. And it's RGB, and I'm getting totally off track. But there's one of them on this. So that's really nice. So you can do some messing around with that. I think we'll actually do a program on that because it's really, really handy. Okay, so, and here's the reason, as I said, we wanted it. There's a RS485 connection on it. And obviously not just a connection, but there's also a chip to go with that. There's an I2C breakout connector on it. Now I did, and there's the WS2818, and as I said, here's the chip. So you power it VCC and ground, and you stream in your data here, and this chip here pulls off the first 24 bits of fines and then passes everything else along. So you just cascade all these chips, and the first one takes the first 24 or the first 24 bits, and then the next one will take the first 24 bits, but this guy strips off the first 24, this guy will strip off the next 24, this one the next 24, next 24. So you end up with each one of them on the line grabs their own data. Very clever system. and I've had great fun messing around with that. So we will definitely do something of that. Here's the GSM connections. This is the just the normal one, and here's the LTE one upside down. Here's the pinouts for the S32, so you can see they're there. And there's the 4 analog to digital. Now, these are the ones I wanted to come back. It says in the document, if I just scroll back up here, I hope that doesn't make anyone nauseous. It's flying up here with this. It says, power out, gone beyond it, digital inputs, analog inputs. It says, here you have to pay attention to one remark. At my disposal is the model KC868-A8S revision 1.0 and has 4 analog inputs. On the manufacturer's website in the specifications there are 2 analog inputs 0 to 10 volt and 2 inputs 4 to 20 milliamps VCC12V1. Perhaps in the new revision of the controller the input circuit of analog inputs have been changed and the configuration has changed. Pay attention to the observation when ordering the controller. Schematic diagram of the analog input subsystem. Okay, what I see they're saying there at some revision, some of the inputs were 0 to 10 volts, and on some of the documentation, 2 of the inputs are 0 to 10 volts, and 2 of the inputs are 4 to 20 milliamps. So I've had a look, and if you go into, so you can go into this diagram here that it gives, and if you pop that up here you can see it's a bit hard to see, try and zoom in here, you can see there is 10k resistors, and you can see here on 2 of them are 150 ohms, so these are presenting a high input impedance. So I reckon these 2 are yes indeed giving you a voltage input 0 to 5 volts. But what's interesting about these resistors here, R69 and R76, they're 150 ohms. Okay, why is that interesting? Well, if you pump 4 milliamps through here, that will develop a 6.6 volts across this resistor, and if you pump 20 milliamps into here you'll get 2 by 150, so you get 3 volts. So 4 to 20 milliamps would equate to 0.6 to 3 volts. So I reckon the 150 ohm resistors here are for giving a 4 to 20 milliamp. Now it's very hard to see on the board here. They are resistors 76 and resistors 150. It's very hard to see the resistance in them or what's marked on them. Okay, I can't. And obviously I can't stick a meter across them because these are across the input of, there's a cap in the way, and then input AA3. So you're looking into the micro here and ground. So I suppose the thing is to try and ascertain, are they different values for the other resistors? So this circuit diagram looks like it would be 4 to 20 milliamps. So what we'll do is I will confirm that. But that's the board. That's it there. It looks really nice. So I am going to write some code. I'll flash up some code. I'm going to put up on the website this is AliExpress Kincony is their official website. And you can see here's the A8 and there's the A8S, which is the one I got here. And this is it here. And you can see that, yeah, the full one was €171.33, which comes with everything, which is the one I got, which is the box and the connector, and there is indeed a USB cable. There is also, yes, an LTE area. This is quite interesting. There's an LTE area. There is, zoom, a 3G antenna if you want to, because there is a 3G pads on it, so I suppose you want to solder it on. Presume that's what that's for. And there's a GPS antenna as well, which is quite nice. So it comes with a GPS antenna and everything. So GPS, that little aerial, and that are all in that little package. There is a programming cable. It's a C. Oh. That is interesting because it's not. Oh, it is. It is indeed. It's a USB-C they've put on it. Okay, I don't know why I'm so surprised by that, but I am. A USB-C cable on it, and the bare bones model is €90. Yeah. So as I said, we got it because we wanted a package, but there's different variants of it there, with or without power supplies, and it shows actually a UK power supply, but this came with a. Actually, didn't even check the voltage. Yeah, it's a standard 100 to 240, and this has a European plug on it. Standard switch mode power supply. It seems a bit light, but I'm sure it will work. 2 amps. I would be suspicious. I know modems in the past. If you're trying to use GSM modems and that, uh, if you don't have a power supply that's able to provide a decent current, if it drops down and dips a little bit, you will get connection issues. So that power supply may not be good enough for using the GSM. But we'll try and give it a run through its test, and we'll see where we go with it. And I'll get back to you one way or another. But so far, out of the box, it looks nice, and I will put up those Kincony links to it. Take care. See you soon.